Hi everybody. So in this video I'm going to be demonstrating how to operate a typical oxy-fuel system. In this video we're going to be using oxygen acetylene because this is what's most widely used in industry because acetylene produces a much hotter flame. And so here we have an oxygen acetylene setup that's fully assembled on a cart, and you can see that the cylinders are secured in place. And on the left we have our acetylene bottle, or what some would call the fuel gas. Now I want to point out that in this situation the fuel gas is a dark color, so it kind of looks like a reddish black. And in some cases the acetylene bottle will come painted red, but using a color-coded system isn't always going to be available. So when you can't identify the cylinder by the color, always make sure to look for some kind of identification sticker that'll tell you what's inside the cylinder. And on the right we have our oxygen cylinder, which in this case is colored green and white up towards the top. Now, oxygen cylinders don't always come painted green, so again, if you ever are unsure of what's contained in the cylinder, make sure to look for an identification sticker that's going to let you know what it is. And as we work our way up the cylinders and past the valves, you can see that there's a regulator that is already attached to each cylinder. And on each cylinder, there's what's called a flash arrestor. This is going to prevent any sparks or flame from entering the cylinder in sort of like a disaster case scenario. So this is a safety feature that should be located somewhere on your setup. Then continuing on, we have the gas hoses that are connected to each one of the flash arrestors. This way the oxygen and fuel gas can be delivered to the torch. And the hoses can be kind of long, but I'm just going to unwind it enough so you can get the idea. And so we see the hoses connect to the torch body as they go through their own separate valves on the torch body. And then up the torch body, we have a cutting attachment that's screwed in place. And at the very end of the cutting attachment, we have a cutting tip. So it's important to know that when using oxy-fuel systems, you have the option of welding and cutting. But for the demonstration of this video, we are only going to be cutting. And now let's take a closer look at the torch body. So as you can see, both gas hoses connect to the torch body, and each gas line has its own valve that allows you to control the flow of the gas into the torch. In order to open the valves on both sides of the torch body, you simply rotate counterclockwise. And then to close the valves, you simply turn them clockwise. Or remember, lefty-loosey, righty-tighty. And then let's get closer to where the hoses actually connect onto the torch body. You'll see that there's one red hose and there's one green hose. And a typical color-coded system would tell you that red is for the fuel gas and green is for oxygen. But what happens if you come across a situation where the hoses aren't color-coded and you really can't see any visible indicators on the torch body that would let you know which gas line is supposed to hook up to which side? Step one would be to simply trace the hoses back to the cylinders and see which side is installed on which cylinder, oxygen or the fuel gas. But now if you're putting together the system while it's just in pieces and nothing is necessarily hooked up yet, and you're starting with the torch body, that can be simple too. So if we look at the brass connections where the hoses will screw into, you should notice a difference. One connector has smooth sides to it, and the other connector has notches that go all the way around. It's universal that the connector with the notches is for your fuel gas, and the connector without notches is for your oxygen. Now this torch does give us some visual indicators as to which side we need to hook the hoses onto. You'll notice that what I'm pointing at to is a capital F, which lets us know that this side is for the fuel gas. And the other side has an O, which tells us that that is the side that we connect the oxygen to. Another key indicator of which gas line connects into which side of the torch is by the threads. Oxygen threads will always be right hand, which means that you'll have to screw it in clockwise in order to seat it into the connector. And fuel threads are always left hand, which means that you'll have to twist the connectors counterclockwise in order to get them seated. Now as we work our way up the torch body and up to the cutting attachment, you'll notice that there's another valve. And while using the cutting attachment for cutting operations, this valve controls your oxygen. And this is going to be your primary oxygen valve for all cutting processes, as you're going to spend most of your time rotating this knob back and forth to adjust your oxygen and your cutting pressure. And you're also going to notice that there's a lever on one side of the cutting attachment. And this is what actually controls the cutting pressure or the cutting oxygen to cut your material. So we see two lines extending from the cutting attachment and into the cutting tip. And you can think of it as your oxygen is going to flow through one, and that is going to control your preheating cones. And then when you depress that lever, it's going to send a high pressure stream of oxygen through the other tube and through a larger hole or a larger orifice in the cutting tip. And that is what's going to give you your cutting pressure. Now, if we should ever come across a cutting tip that appears to have some debris blocking one of the orifices, or if one of the orifices happens to get plugged up during use, we need to learn how to clean out the tip. And so what I've got here is a package of tip cleaners that are to be used with cutting torches and welding torches. And it may be a little difficult to see in the video, but these are essentially small round files. And so all you have to do is find the right size tip cleaner and slide it into the orifice. It should go in relatively easy. If you feel any kind of pressure other than what the blockage is giving you, you might want to double check to see if you have the right size because we don't want to accidentally break off a tip cleaner into our torch, because then we have to switch out the tip for a totally new one. And really, it's as easy as just sliding it into one of the orifices, feeding it back and forth just to dislodge whatever's blocking it, and you're good to go. And now let's introduce the striker. This is the tool that we're going to use to light the torch. Remember, you should never use matches, a lighter, or the arc of somebody welding. You should always use a striker tool. This is one variation of a striker, and there are a couple others out there, but this is what you'll typically find in our shop. It's a fairly simple design. It's a little wire frame, and on one side of the wire, there's an abrasive material, and it's encased in a little housing unit. And on the other end of the frame, of the wire frame, there is a flint tip, which scratches across the surface of the abrasive material, and that's what creates the spark. Now, the key thing to remember here is that simply sliding the flint tip against that little abrasive piece of material isn't going to create the spark alone. You have to deliver a little bit of pressure. So you have to push down on one end of that frame that holds the flint tip as you strike it across or push it across that abrasive piece of material. Now let's take a look at the pressure regulators that are attached to each cylinder. Starting with the oxygen regulator, go ahead and pause on this image and just take note of any little things that you notice about it. Now take a look at this image, which is also of an oxygen regulator, and see if you can point out some of the differences. I think the first difference you're going to notice is that the regulator that we use in the shop places both gauges on top of one another, while the second image places the gauges next to each other. Don't let that throw you off when it comes to determining what gauge is telling you which pressure. Because another thing that you should have noticed is that one gauge measures up to a much higher pressure than the other. So in terms of PSI, or pounds per square inch, one gauge is going to read into the thousands, while the other gauge is only going to read into the hundreds. The gauge that reads into the much higher numbers, or in this case the thousands, is going to tell you the pressure of the cylinder, and this is going to let you know whether or not your cylinder is full or empty or somewhere in the middle. And the other gauge is going to tell you your working pressure, that is, the amount of gas that's flowing through your lines. Let's take a look back at our regulator that we're going to be using in the shop. And so as I open up the cylinder by twisting the valve counterclockwise, you'll see that the top gauge begins to move. And it's going to go ahead and give us a reading of just how full our bottle is. Whenever we're conducting oxy-fuel operations, our oxygen cylinder needs to be opened up all the way. So I'm going to continue opening this valve counterclockwise until I can't anymore. Now to set the working pressure, we have to work with the valve that's located on the side of this regulator. Now pay close attention to the bottom gauge, or the working pressure, as I rotate the adjustment knob on our regulator clockwise. And you can see that our working pressure begins to build. Now, depending on the size of your cutting tip and the thickness of your material, that's going to determine exactly what your oxygen pressure is going to be. So you can expect to be anywhere in the 20 to 40 psi range. And now let's take a look at our acetylene regulator. You'll notice that the gauges are on top of one another, just like the one on the oxygen cylinder. And so just with the oxygen regulator, you'll notice that on this regulator, one gauge reads into higher pressure settings than the other. And the one that reads into the higher levels of PSI, that's going to be the pressure for your cylinder. And the one that doesn't go as high is going to be your working pressure. Now with acetylene, it's important to never set your working pressure above 15 psi. It's just a huge no-no, and I'll get to that in a different video. So now let's take a look as I open up the valve on the cylinder, and we can start to see these gauges move. Now another thing to be aware of with acetylene cylinders during oxy-fuel operations is that you should only open the acetylene bottles approximately 1/4 turn to 1.5 turn. And this is also something that I'm going to address in a separate video. Now the working gauge gave me a reading which tells me that the last person to use this didn't back out the adjustment knob all the way. But that's okay, I'm going to go ahead and walk through all that nonetheless. So to increase the working pressure, we're going to rotate that adjustment knob on our regulator clockwise. And you can see the pressure building up. Now what happens if we built up too much pressure and we need to lower it? Well, it's not as easy as just backing out the adjustment knob, although that is going to be our first step. So in addition to backing out the adjustment knob, we also need to bleed the lines. So we're going to have to get our torch and open up whichever valve corresponds to the gas that we have set the pressure too high on, and just open it up, let it bleed out, and then we can reset our working pressure. And here are some recommended pressure settings for oxygen and acetylene as published by Victor. So I know there's a lot of stuff on here, but the only 4 things you should really be looking at are the metal thicknesses, the tip sizes, the cutting oxygen pressure, and the acetylene pressure. Those are the 4 things you need to look at when determining how high you need to set your pressure settings for oxygen and acetylene. Here I'm going to demonstrate a dry run on how to light the torch. So the first thing you're going to do is you're going to crack open that valve for the fuel gas just enough to allow it to flow into the cutting torch and out through the cutting tip. Once we've done that, we're going to take our striker and we're going to light the flame off the side of the cutting tip, never directly in front of, always to the side. Now remember, while we're using a cutting attachment and we're using the torch to cut materials, the oxygen valve down at the body of the torch body needs to be open all the way because it's the oxygen knob up towards and closer to the cutting tip that we're going to be mainly dealing with. So after we've cracked our acetylene and we've lit the flame, we're going to go up to that oxygen valve that's higher up on our torch, and we're going to crack that one open as well, and that's going to allow us to adjust our flame to a neutral flame for cutting. So let me go ahead and run through that again. First, we're going to make sure that the oxygen valve down where our hoses connect to the torch body is opened up all the way, because as the oxygen flows to the torch body, it's going to be that second oxygen valve that we're primarily going to be dealing with. Then we're going to slightly crack open the acetylene valve just to get enough of that gas flowing through our torch and out our cutting tip. Then we're going to use our striker to light the flame, and again, remember, we're lighting the flame off to the side of the torch. And from there, we're going to crack open that second oxygen valve to adjust our flame to a neutral flame for cutting. Alright, so here I've got my steel and I've got some stuff drawn on it. I'm going to cut across a straight line, but I've got some other figures drawn on there just to kind of get the point across that using a cutting torch, you don't just have to stick with straight lines, you can also cut out curves and different shapes. And so you can see my little plate of steels kind of hanging off of this little platform. That way nothing gets hung up as I'm cutting through the material. I've got another block of steel sitting on top of the plate to ensure that it doesn't fall off. Now, assuming that we've already lit the flame and we've achieved a neutral flame for cutting, I'm going to go ahead and start walking through the steps. It never hurts to preheat your material before cutting, especially if you're working with something that's a little on the thick side. And it's as easy as just going back and forth over the line that you intend to cut. Once you're satisfied with the level of preheat that you've achieved, you can go ahead and shift your cutting torch over to the beginning of your cut. Now I'm right-handed, so I cut from right to left. If you're left-handed, you're probably going to go from left to right. You're going to wait until the material gets to about a cherry red, maybe a slight orange glow, and then you're going to go ahead and introduce that cutting pressure oxygen to make that cut, and then you're just going to follow through with the rest of your cut, trying to make sure that you hold on tight to your torch and you're not wiggling around. You want to try to get this cut as straight as possible. Now, another thing to keep in mind is that depending on the direction of travel, you want to aim the cutting tip in the direction that you're cutting. So I'm right-handed, so I want my cutting tip to face a little bit more towards the left. So I'm showing you here what a 90-degree would be for the cutting torch. And what I mean by angling is facing the cutting tip in the direction that you're cutting. So I'm kind of exaggerating a bit right here. You shouldn't actually have this angle. This is just to show you what I'm talking about. And here I've got the brightness turned down a little bit so that way you can see the flame a little better. So here I am lighting the torch, setting my acetylene. Now I'm at a screen, but I'm adding my oxygen to get the neutral flame for cutting. And so what I'm going to do first is I'm going to preheat my material. It's a little thick, so it can stand to get some preheat. And you can see the moisture being pushed off to one side as it evaporates. And now as I move back to the edge of the material where I'm going to start my cut, I'm just going to move a little bit up my plate so that way I can show you just how long it takes for the edge of the material to heat up enough to where we can start our cut. Or rather, I should say the short amount of time that it takes. And I'm just going to jump in really fast to that same spot to demo what happens if you try to cut too fast. About 1.5 inches into the plate, I'm going to go faster than what my torch can heat the material up in order to cut it. And you're going to see that if you go too fast, you simply just can't cut the material. So you're going to find yourself having to backtrack and then heat the metal up again to its melting point and then start your cut again. And here I'm just going to continue on with that cut, and I'm going to demonstrate what happens with a couple instances of getting too close with the torch and cutting too slow. So sometimes if you get too close with the torch, what will happen is you're going to overheat the material on the surface and it's going to cause it to pop, a little bit like boiling water. So if you pay close enough attention, you'll notice that that happens 3 times during this cut. Another thing to pay attention to are the sparks that are coming underneath the material as a result of your cut. You should be mainly seeing sparks coming out from underneath, and if you start to see globs of material, that's a key indicator that you're cutting too slow. Okay, so I've zoomed in a little bit and I've added a filtered lens so that way you can see the flame and the cut a little bit better since before it was kind of bright. And I'm just giving that piece of material a little quick preheat, and then I'm just going to jump right into the cut. And I'm still making this cut a little slow just so you can see that it doesn't take that much time at all to cut your material. And here's another angle of looking at the cut. And here's a real close-up slow-mo of me starting one of my cuts. I'm including this in here because I always get the question of, well, how far away from the material should I hold the torch? And my first answer is, well, obviously, never hold the cutting torch right up against your material. And a couple of things to take into consideration are the size of your tip and the size of the material that you're cutting. My own personal rule of thumb is that I always give about 1/4 of an inch between the material and the tips of those small little preheating blue cones that you'll see going around the surface of the cutting tip. And assuming that you've cut your material properly, which in this case I did cut a little slow, so I'm expecting the piece to kind of stick to it. But if you cut it properly, the piece that you've cut should fall right off. In this case, it didn't, so don't be afraid to take a hammer to it and give it a couple love taps in order to separate the two pieces.